Hello, everybody. This is the first class of the aviation workshop from the Wilcox Aviation Club. This is an introductory workshop meant for students who have an interest in aviation or aspiring to get into the field. So, without further ado, let's get into it. In today's class, we will be defining what aviation exactly is. Next, we will move on to the four fundamental forces that act on an airplane during flight. Lastly, we will talk about the different parts of an airplane and their purpose. Aviation refers to the activities associated with the design, development, operation, and flying of the airplane. So, companies that you have probably never heard of, such as Boeing, deal with aviation. Aviation is split into specific categories such as commercial, military, and unnamed aerial vehicles, which are basically drones. If you're taking a plane to go into another country, it would be a part of the commercial sector of aviation. The military deals with aviation when it creates fighter jets.
Let's go over the four fundamental forces. During flight, there are four forces that act on an airplane. These forces are lift, thrust, weight, and drag. When an airplane is traveling at a constant speed, these four forces cancel each other out. Usually, aircraft manufacturers try to maximize lift and minimize drag. We will go into these in detail. Lift is the force that keeps an airplane up in the air. Most of the lift of a plane is generated by its wings as the plane moves through the air. Lift acts in the opposite direction of weight. Aircraft manufacturers experiment the shape of the wings to maximize lift. They specifically experiment with the airfoil section, which is the cross section of the wings. Lift happens when there is motion between the plane and the air. For example, if a plane does not move, lift won't be generated. Lift is especially needed during takeoff. In order for the plane to successfully go into the air, we will go into how lift is generated in the later sessions. Drag. Drag is a resistance that plane encounters as it moves through the air. Drag tries to slow down the plane. The air particles push back against the plane during flight, which cause it to slow down. There are many factors that impact the size of the drag force, such as the shape of the airplane. For this reason, aircraft manufacturers try to reduce drag by making more aerodynamic shapes. They do this to go faster and reduce fuel consumption. You can feel drag by yourself. Next time you're in a moving car, stick your hand out. You will feel the air pushing back against you, which is drag. On the left, we have two hypothetical airplane head shapes. On the top, we have a triangular shape. Over here, we see there is little drag because the air particles are going over the head. The air particles are not trapped, whereas in the bottom diagram, due to the shape of the box, the air particles are stuck in the front of the plane. Because of this boxy shape, the planes have more aerodynamic drag. Aircraft manufacturers play around with the airplane head shapes in wind tunnels to limit drag. More on drag. These are just examples of drag reductive shapes. As you can see, even F1 cars use these aerodynamic principles. These designs try out to cut through the air particles instead of trapping them. Let's add another layer to the experiment we did on the previous slide. First, hold your hand out of a moving car. Position your hand so your palm faces in the direction of the car's motion. Next, rotate your hand so that your palm is facing downwards, which position felt less resistance. Weight and thrust. Weight is the force of gravity that pulls planes downwards towards the earth. Weight, or the force of gravity, is the reason why we come down when we jump up. Aircraft manufacturers try to use lightweight materials such as aluminum to make the plane in order to maximize lift. This is because weight counters the force of lift. Thrust is the force that propels the plane forward. The force of the thrust counters the force of drag. In order for the plane to accelerate or speed up, thrust of the plane has to be greater than the drag. Thrust is usually generated by propellers or jet engines. Propellers work by pushing air backwards, which makes the plane go forward. Jet engines also make the planes go forward, but through a different, more complicated mechanism. Smaller planes, such as the Cessna, use propellers, while more high speed planes, such as the F 22 jet, use jet engine. The top example is a image of a propeller plane, and the bottom image is of a jet engine.
Okay, so now let us start with the parts of a plane. We will be covering the major parts of a plane, and we'll go into more details into the specific parts of each plane in the later sessions. This is just the basic introductions to the parts of a plane. So first off, let us start with the fuselage, which is also known as the body of an airplane. This is the metal tube that holds all the parts of a plane together. So, for example, in the image, the fuselage, the red thing, holds the tail of the plane, the wing, and the nose. So, it can be called the spine of an airplane. If you have ever traveled in a commercial plane, the fuselage is probably where you have sat in. And the fuselage normally or usually is used to hold passengers or cargo. However, plane manufacturers, they usually vary the size of a fuselage depending on the plane's purpose. So, for example, a commercial plane would usually have a larger fuselage because it needs to optimize the amount of cargo and passengers. However, on the other hand, a fighter jet, it doesn't need to have that big of a fuselage because it needs to be light, it needs to move quick throughout the air, and it doesn't need to hold that many people. So a fighter jet would have a smaller fuselage. So next up, let's move on to the wings. The wings are like the arms of an airplane that stick out from the side. The wings are used to generate lift, and without it, a plane would not be able to fly. Airplanes generally have different types of wings, depending on the plane's purpose. So, for example, a fighter jet has swept back wings called delta wings. Jets need these types of wings because jets need to fly at extremely high speeds. However, on the other hand, commercial planes don't need that like delta wings. They have more triangular shaped wings, just as shown in this image. So as you can see, aircraft manufacturers optimize the wing shape to maximize lift and minimize drag, depending on the plane's purpose. So now let us move on to the horizontal and vertical stabilizers. Both of these stabilizers are located at the back of the plane, and collectively they are known as the tail section of the plane. The horizontal stabilizer, which is this over here in blue, prevents the plane from randomly wobbling up and down on the vertical axis. And the vertical stabilizer, which is this, the red one, prevents the plane from randomly wobbling left to right, side to side. Both of these, the tail section, make sure that the plane stays on course and doesn't sway too much. These two parts function together to make sure that the plane remains balanced in flight. So these stabilizers contain two control surfaces called the elevator and the rudder. So this is the elevator over here in blue, in a lighter shade of blue, and this is the rudder in a lighter shade of red. The elevator helps the plane go up and down. As you can see, the elevator is folding in this image, but the rest of the stabilizer is not bent. It is straight. And the rudder helps the plane go side to side over here. So the pilot controls these control surfaces when flying so that the plane gets to the right destination. Now let's move on to the landing gear. The landing gear allows the plane to move on the ground during takeoff and landing. The plane retracts the landing gear once it is successfully in the air. So the plane uses these landing gears, these wheels, to take off from the ground. And once it's in the air, it no longer needs these wheels. So it just retracts them into a safe place. And the plane would need these wheels again when landing. So it calls them back. Without the landing gear, a plane will land on its fuselage during landings, which is not at all good. It is extremely dangerous. And different planes have different types of landing gear configurations depending on their size. So this is an example of the landing gear. And this is an example of a plane using this landing gear to take off. And once it's in the air and doesn't need them anymore for a while, it'll retract the landing gears. And retracting the landing gears will actually decrease the drag felt by the plane, which is what aircraft manufacturers like. And we'll go more into detail into the next few sections on this. So now we have the cockpit. The cockpit is where the pilot sits and controls the aircraft, and it is at the front of the plane. So this is an example of the inside of a cockpit, and it is similar to a driver's seat in a car with many more controls. And this just goes to show how difficult it is to control a plane, fly a plane, because there are so many different controls. And the pilot of a plane can control the upward, downward, and left to right motion of the plane in the cockpit. So it is where all the controlling of the plane happens. And lastly, we have the propellers. The main job of a propeller is to generate thrust for the aircraft, and it does this by pushing air backwards. The propellers push air backwards so that the plane can move forward throughout the air. And besides generating thrust for the plane, besides moving the plane forward, the propellers also help generate lift to help move the plane upwards, very much like the wing. But we'll go more into detail into this in the later sessions. And another method of generating thrust besides propellers is a jet engine. And jet engines are another method of generating thrust, but they are much more complicated. And jet engines are used for planes that need to go at extremely high speeds, like a fighter jet. So this is an example of a plane that uses a propeller. And a propeller, it could be compared to a ceiling fan. So when you turn on your ceiling fan at your home, you feel a rush of air coming towards you. This is because the ceiling fan is pushing air downwards onto you. And the propeller, it essentially does the same thing, except it pushes the air backwards, which helps the plane move forward.